a science news article popped up on my feed, and it prompted me to basically make this. The article in question is by Emily Connor, or Conover, in sciencenews.org, I believe. It's about how electrons are near a perfect round, or at least with the best measurements that they are performing in this way, to be able to get a very accurate reading. Now, I've had some issues with how it is we do some of the science and experimentation and how we gather the data. The reason why I've had this issue for a while, and I might not be understanding that they already do this, okay, but it's because of QAnon and other such retards that exist in this world, that vote with you and I, that will ultimately just disbelieve a lot of this, and are clearly just irrational, gaslighting fearmongers. Or those that are not that and know how to stoke those people up. And these are the real, actual, dangerous ones that I'm really trying to get this across for people to understand why it is I have these issues. Okay, these issues stem from a fear that because they are intelligent enough to understand where and how it is this is done and could try and elicit a degree of uncertainty over these measurements, that these are the reasons why I'm stating this. Okay? To try and get people to disbelieve and discredit physics as we know them. Although, to a degree, I do believe that they could possibly be updated, just like any other damn thing that we've ever done. You know what I mean? So, the measurement was performed using a field that was to exact a degree of torque on the given electron, and if whether or not it was more egg-shaped, try and do the egg, kind of oval, versus more perfectly round as a whole. All right. Now, the way they were measured is twice, in terms of its performance and accuracy. The reason why I have issues with this is how they measured the given energy value in the hafnium fluoride that was used, or fluorine or something. They didn't really state this in the article, so again, this is why I preference it by stating, hey, maybe they did do this. You know what I mean? But they are not accounting for the given bell curve of standard model probabilistic factors that go into play when it comes down to the detection, meaning the detector actual apparatus, like the thing that actually measures shit. The given down the line individual electron orbital and nucleus interactive forces that eventually amplify a given mechanically is effectively how I view it. By stepping up a given interaction to the point where, in an amplification-like manner, we view it as a volt increase or decrease or some other type of thing like this, and we use programming to ultimately determine that this is what it meant. Okay? We're not taking into account the given degree of uncertainty that is created during this. All right? And the level of interactive interference forces that can be destructive and constructive in various manners. Now, we layer it as best we can. There's obviously a degree of impurities in all of our given detectors. All right? We try our best. But we're not accounting for that degree of probability, in that. And that bothers me, okay? That alongside of how much that can give us a distorted view, I suppose, of what it is our results end up looking like. And that causes me a lot of anxiety, because science deniers, physics deniers, people that deny reality will try and use this to fearmonger and deny what is ultimately for sure happening around us. Wave functions are what they are. Okay, and we understand that wave functions exist, but we're not really trying to do the wave function probabilistic factors in these detectors that we need to when we're talking about the very subatomic quantum fucking range that we are honestly getting to. We have to have that there. It's pedantic to some, it's not pedantic here. They are important. These wave functions are enormously impactful on what our results will look like, especially with how it is that we set up the given data to be achieved in a more realistic and a less realistic manner, meaning colder, less realistic, but much more controlled, less variables to take into account environment, and a lot more realistic, which has more noise, which is what they call it, but it's not noise, but I suppose it's noise. It's more like these are a bunch of forces that are clearly going to interact and interfere with each other that are not being accounted for within a box in multiple layers to be detected as they go through, and the resulted detection and the loss of energy accounted for as it goes through to the point where we are doing the detection. Same thing with the given energy imparted with if they were using lasers or a, allowed to circuit design, meaning closed circuiting detector to see if in certain very small areas they were getting a voltage increase that was nominal, what we expected, or greater than what we expected. Okay, all of that can be a pretty noisy type of thing that can affect our results in data analysis. Okay, especially with resistance and field losses, as a given electron is measured for its given energy level and its orbital field. That resistance needs to be accounted for, not just from the substance you're detecting, because of course you're not doing it atom by atom by atom, most likely, but if you did, great. You didn't take into account the field loss in creating electromagnetic fields through the given cable that is ultimately there, or the conversion of having it tunnel jump, and affect the cable in such a way that you get a result. Okay, like that's a big deal, and that can be if there is any level and degree of interference forces and interactive, constructive, destructive forces, then we're getting a point where it can be higher or lower, or look like it is more nominal when it is not actually the same as we previously thought. Okay, this is where I have those issues. Okay, I'm just asking for a better detection and accounting of the detection and results that we get. Only because I dislike science deniers. I dislike physics deniers. I believe in physics. I do. I genuinely feel as though, they're probably not wrong. For what it's worth, electrons are most likely quite round. That being said, it makes it a lot easier to just straight up try and become a bullshitter in that field when you know how to bullshit right. Because it's like, well, you didn't account for this. Well, you didn't account. And it's like, you sound like my fucking parents. You know what I mean? Like, you didn't account for. And it's like, I know that that's true. See, this is the problem. Like with my family, I know that they're true. On that one, like that, they're saying the right thing. Like I should account for that. Like honestly, they're right. You know what I mean? But despite that, I'm also like, it's still very round. And then it's like, but here's the thing, as the me now that grew up, as round as it might be, it doesn't change that when we're talking about the Big Bang and how small that really is and how rapidly that really became. That is what this is measuring for, is massive. Even if it's not near perfect, and in fact it is perfect, well, that would then account for some things, but there's rarely ever perfect in anything, okay? And it's like, I am perfect. No, you're not. You're not. An electron is not going to be perfect. And so, obviously, that's going to change things, especially at those enormously high energy and impactful over time phenomenon going on. Okay, those electrons are going to mean a lot if they're even slightly off. And again, we have to remember, if there are virtual particles that are forming that ultimately impact that, that also gives us an idea and clue as to how it is this formed. If we're not taking into account how often the general field is ultimately producing one or another, or where, meaning a little bit further over here versus over there, because maybe it's allowing for a given constructive force or dumpage of that energy into something of another electron, or perhaps another particle, field, whatever it is going to ultimately amount to a massive change in what the results are going to look like. And so I love the science. I think that that's a great way to go about it. But at the same time, it's not. The given energy input, which has to be calculated for all the given little tiny fucking little itty bitty bell curve standard matter probabilistical factors, over the given amount of hafnium fluorine, for all the likely densities that exist within all of the blah 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 blahs, meaning little shapes and mineral, crystalline structures and so on and so on and so on and so on and so on. And then ultimately how the field will dump its given energy in one area because it's traveling a given direction versus another, which they're like, no, fields don't travel. No, an electromagnetic, electrostatic, any of those fields do have travel. They do have a given shape. All right? They have a given directionality. They align things, okay, for what it's worth. And as a result, they can impart along the outside versus the inside, or the inside, and it all depends on the frequency at which they are at. Whether or not it is this given voltage or that given voltage can change its frequency. Frequency is a big deal. Lower frequencies and higher frequencies, we all know, go in or less in to various different material. And so it doesn't seem like it's a great big deal, but it is. Okay, it's a huge deal. And if it's not being done and accounted for, it's going to mean a lot of that seemingly good data that was measured accurately is actually not good data that was measured accurately. That's the big problem I'm having. And it wouldn't take much for me as a science enthusiast to debate them about that. If they're not accounting for this, which they might be, then we have a problem. It means the data is not very accurate. It means we can't really use it. It means the ever-loving shit out of all of that data, which might be collected many, many different ways that are very, very similar to that whole problem of not accounting for in and out and all the rest that interact and the likelihood therein of the given volume and space of that given energy input is to occur. It should be in line with our predictive analysis. Okay, it should be in line with what it is that we know. But then there is always the chance that we are simply not aware of how an interactive force and or interference forces will ultimately go in or depart more on the out and drain and then actually create their own given wave functions that travel in and how long they languish around for and bleed off. Okay? Given the temperature, given the oxygen content or not, given any of what's in the atmosphere, how cold, all of this is going to play a huge role. So, they might be accounting for all of this. If they were, that's great. Right? But we're not accounting for the given spin. We're only accounting for the given volts and or other given field in the electron orbits, strengths, based upon either laser analysis or a circuit-based design where they try and detect what is there over that given area. Okay, now they might have a entirely better way of doing it than I'm aware of, which would be great, and all my fears can be totally assuaged. Super. But this is the reason why I have these issues. Nothing against the scientists and physicists. I'm on your side in a lot of ways. I do believe they're probably quite round, but any of that can alter dramatically the results, and it needs to be accounted for. And so, like, when it's an article that has a title like this, it tends to trigger me. It does. No offense to Emily. But it does. It does give me a bit of a trigger, because that's not the only one I see doing some issues like this. Even when I get into the nitty-gritty science where they publish in PubChem or something else, and they are not accounting for that data, especially when it comes down to statistical averaging. Okay, like statistical averaging of aggregation of given data values will give them a plus or minus, which is not correct. They can be more certain than that, which bothers me. It gives me in a massive way a trigger. Like it's like literally, oh wait, I get Heisenberg's uncertainty principle, but we can average way harder than a plus or minus of 1 or even 2%. Okay, like, and truthfully, there should be a bell curve statistical analysis of which there's more like this, which has a plus or minus, and then further over all the way to the left, which has a greater degree of gradiency, and we would want to know why. That's a big deal. That massively can change a large percentage, especially when we're talking about wave functions that, like, I get this, we're multi-dimensional aspect people, okay? All right, so we're just 3, right? Like, we view 3, but like, no. This little part of my skin is connected to this little and there's a whole bunch of little different freaking connections all the way over to the point where it's in the back of my skull, and we have a lot of different connections there, which is many dimensions that greatly affect what this little part right here is going to do. Okay? As a result of that dramatically changes what a wave function is going to look like. A person imagines a 2D sheet of paper. That's not what a wave function is. A field is a genuine ocean, and it's very multidimensional, and it has many different degrees of spikes, and degrees of roundness, and degrees of curve into self, meaning concavity and convexity, and more. So, this is the reason why I go, is it really what you think you are saying here? Because wave functions and standard model tell us you're wrong. They should in no way look like that. That's the point I'm trying to get across. What they just stated for this given setup really only states that the standard model either has massive issues or the way they detected something is enormously not correct. And that's what I'm trying to drive at. All right, have a good one. I'm actually on your side. Just try to remember that. Yeah.